Hello everyone, welcome to the video demo presentation of Politecnico di Milano's activities. My name is Davide Scazzoli and I'll present the main achievements shown throughout the rest of this video. Our first result is the RSSI-based localization. We used a combination of different technologies shown here in the right, which allows us to broadcast a reference signal from the drone, have the ground UE measure it, and relay back the information to the drone for localization. Here you can see it working in real time.
Into our localization, 40, 50. Yeah, we are getting around, on an average, if you take here, we're getting 45 and 53 more or less.
Okay.
So 70, yeah, 74, 72.
Perfect. So we are double checking the distance with the onboard sensors of the Matrice.
Our next step is replicating the open-air interface setup used in Tallinn and show the drone-to-drone relay capabilities. For this test, we used both drones that we bought with the funds from the project. Here you can see open-air interface starting up on the ground user equipment, or UE. First, on the top left, we initialize the soft modem, which takes care of the physical layer, MAC layer, and synchronization between the devices. To provide synchronization between all the devices, a GPS discipline oscillator, or GPS-DO, is mounted inside the communication equipment used. This provides a stable 10 MHz clock, which allows for a quick connection. Once the soft modem is initialized, we start the device-to-device or P2D application, shown in the top right, which takes care of the higher layers of communication such as network and transport layers. In the bottom left, you can see us starting a ping to another device to show that we have a connection established, as well as the results of a previous ping done on the ground to check that everything works before takeoff. After our flight, we stopped the connection to display the results. The relatively high packet loss is due to us using an unlicensed band which is subject to interference. We now move to the relays on board the UAVs. Again, we perform the same procedure, only for the relay we do not start any ping, as it instead acts as a relay between the other two devices pinging each other. Moving to the last step, we now test a direction of arrival estimation algorithm based on an antenna array. Here is shown the design of the system. In particular, on the right is shown the synchronization procedure, which alternates antenna signal and noise signal, the impact of which will be shown later in the results. Here instead is the practical implementation of the design. On the left are two antenna array ports which we designed and produced. On the right is the coherent receiver which connects to the antenna array. And in the middle you can see the drone equipped with all the necessary hardware. For the purpose of this demo, we left the receiver on the ground to monitor its output. To understand the results, let's look at the geometry of the system. The drone is flying at a certain height and a certain distance from the receiver on top of the car. This describes an elevation angle which we'll identify within our results. The other variable to be measured is the azimuth of arrival, which is the direction we have to point to find the drone on the ground level. Here in the video we see the drone rotating around the car while maintaining its altitude in order to change the azimuth of arrival. Here instead we can see a few examples of the direction of arrival estimation algorithm working, with a graph showing where the power is coming from in terms of azimuth and the elevation of arrival in the x and y axis respectively. Note that sometimes the power disappears. When this happens, we are simply receiving the synchronization signal rather than the antenna signals, as shown previously. Here we have moved slightly closer to the car, and you can see that the power was increased to 30 dB max on the scale. Thanks to the support of this project, we've been able to achieve these results. Many students were able to work on the hardware shown in this video and complete their master and PhD thesis, supervised by experts in the field of telecommunications. Thank you for your attention. Feel free to ask any questions.